Okay, so our lesson for today involves the concept of inverse functions. And in order to talk about inverse functions, we have to decide what an inverse function actually is, or even in mathematics, what is an inverse operation, or what does inverse mean? So to lay that groundwork, I want to talk about how there are inverse operations at each level of mathematical operations. So we talked about our hierarchy where we had actually addition and subtraction were at the bottom, and then we had exponents and roots at the top. And I think at that time we even alluded to the fact that that there were inverse operations. Addition makes something grow, subtraction makes it shrink, but addition grows at the same rate that subtraction shrinks. And here's what I mean by that. If I add 3 and then I subtract 3, it's like nothing ever happened, right? I add 3, subtract 3, it completely, it's like we're back to 0. Nothing happened. Same thing happens with multiplication and division. If I multiply by 3 and then divide by 3, again, it's like nothing ever happened. We're back to where we started. And then lastly, with exponents, if we square something and then we take the square root, same thing happens. It's an inverse operation. We end up back where we started. So an inverse is something that undoes something else. What does that mean when it comes to functions? What could an inverse function mean? So in order to explain that, let's take a look at our canvas. And I'm going to give us an example of a function. So I will call it f of x equals 3x plus 2. So this is a linear equation. We could graph this if we wanted to. We'd probably want to think of it more in terms of y equals 3x plus 2 if we were going to graph it. But it is a linear equation. What does this function do? Well, what it does is if I were to input a number, if this was like a little number machine, like I've said before, I would drop a number into this x. Let's say I dropped the number 4. Drop it into the number machine. The first thing that happens is I take 4 and multiply it by 3, which turns it into 12. And then I add 2, which gives me 14, and then it outputs that number. So I put in 4, I get out 14. That's my little number operation, that my number transition that's gone on. So an inverse function should do the opposite. If inputting 4 into this equation gives me 14, then I should be able to find an inverse that will take 14, stick it in, and I will get out 4. So it will do the opposite. F of x takes 4 and turns it into 14. An inverse function should take 14 and turn it into 4. Now, how are we going to create a function easily? I mean, we could kind of take some time to think about how to do this, just kind of guess and check or whatever. But there is a nice, simple way to complete this. So the first thing that we're going to do is I'm going to rewrite this just as y equals 3x plus 2 because it's a little bit easier to see our input and our output variable. So input x, output y. So an inverse operation takes x turning something into y and flip-flops it so that y can turn something into x. So how could I make my function do that? Well, it really is just as easy as flipping the variables. So if an inverse function takes the input and the output and turns them around, all I really have to do is go to my equation and switch the variables. So let's take, instead of y, I'm going to put x, and instead of x, I'm going to put y. And believe it or not, that's it. That's the inverse function. So all that working up, and that's all that it is. Now there's only one thing I really don't like about that, which is when do we ever see a linear function written as x equals? Not very often. So creating an inverse function is not that complicated, but rewriting it takes a couple of steps. So what I'm going to do is I'm just going to try to get y by itself. So I'm going to subtract 2, that gives me x minus 2 equals 3y. Then I'm going to try to get y totally alone, so I divide by 3. Remember, it kind of has a distributive effect. X divided by 3 and negative 2 divided by 3, that's going to basically be 1/3 x minus 2/3 equals y. Now just a short math moment here. If you're wondering, where did I get 1/3? Remember, x is just 1x. So when I divide by 3, I can write that as 1/3. Could I also just write it as x divided by 3? Yes, but if I ever wanted to graph this equation, I'd kind of want to have it written as a fraction, because that's how we graph slope and y-intercept. So here I have, I'm going to kind of turn this around because I have the y on the right and the numbers on the left. So I have y equals 1/3 x minus 2/3. And according to what I've just told you, this should be our inverse function. How did we do that? Again, we started with a function. We flip-flopped the variables, so flip x and y. And then we just solved for y, just to make it into a nice form. And what we get is over here. This is what we get. So the question is, if I put 14 into this equation, is it going to give me 4 the way that it's supposed to? Let's give it a shot. So input 14 into the x. 1/3 of 14 is just going to be 14/3. I'm going to write it over here where we have a little room. I'll draw a little line, kind of make a little section here. So 14/3 minus 2/3, right? So I've put 14 in. 14 times 1/3 gives me 14/3 minus 2/3, which is 12/3, which 12 divided by 3 is 4. So did it do it? Yes, it did. The inverse function, we said, should take 14 and turn it into 4, and sure enough, it did. And that is it. That's all there is to making an inverse function. So, in short, coming back here, if you have a function, any function, and you want to find the inverse, or what will undo anything that that function does, you just take the x and y and you change their spots. That's all it takes to create an inverse function. And then if we want to put it back into y equals mx plus b form, we just rearrange the equation from there. But that is really all there is to it. So topic 1, that's it. Topic 2, we're now going to talk about what this means graphically for a function and an inverse.